Pre-absorption, also cross-absorption, is an additional purification step introduced to increase the specificity of a secondary antibody and eliminate reactivity against undesired host species. Secondary antibodies can be pre-absorbed against serum proteins from another species or against a mixture of serum proteins from several species. These secondary antibodies show extremely low levels of cross-reactivity, typically less than 1% of the desired signal, which allows the use of multiple primary antibodies from different host species in a multiplex experiment. It is also recommended to use secondary antibodies that are pre-absorbed against the species of the sample. Fab fragment antibodies consist of the 50 kilodaltons monovalent Fab antibody portion of an antibody molecule. Fab fragment antibodies are generated by Papain digestion and subsequent purification. These fragments lack the Fc portion of the molecule and will not interact with the Fc receptors and thus eliminating nonspecific binding in affected cells or tissues. The size of these reagents maximizes penetration in the IHC applications. Unconjugated Fab fragments can also be used to block endogenous immunoglobulins on cells and tissues when using primary antibodies from the same species. Also, in contrast to the divalent Fab2 fragments, the monovalent Fab fragments allow double labeling experiments with two primary antibodies from the same host species. Fab2 fragment antibodies are generated by pepsin digestion of whole IgG antibodies to remove most of the Fc region while leaving intact the hinge region. Fab2 fragments have two antigen-binding Fab portions linked together and have the full antigen-binding capability of full-size antibodies. Like Fab fragments, Fab2 fragment antibodies eliminate nonspecific binding between the Fc portions of antibodies and tissues or cells expressing Fc receptors. Fab2 fragment conjugated antibodies are ideal for flow cytometry, immunohistochemistry, and immunofluorescence. Antibodies raised against the heavy and light chains of an IgG molecule will cross-react with other immunoglobulin classes, such as IgE and IgM, by binding to the shared light chains. The wider range of epitope binding sites, however, makes them the most universal secondary antibody type for immunoassays. Fc-specific secondary antibodies are class-specific and do not cross-react with other immunoglobulin classes by binding to the shared light chains. They are less prone to cross-reactivity than antibodies that recognize full IgG molecules.